Hello, welcome to Math with Mr. Dobrescu to the rescue. Today I'm wearing my favorite color, green. Because green stands for proficient. I want all of you to be proficient in mathematics, and when you are taking that test at the end of the year, I want everyone to be proficient or advanced. Today we are going to look at identifying similar triangles. Similar triangles have something in common. Similar triangles have all their angles the same. Okay? All their angles have to be the same. Now, at least two of the angles in each of these triangles have to be the same. So if we have two triangles and we have some angles in this triangle and some angles in this triangle, if we at least find how many angles? Two angles. If we at least find two angles the same in each triangle, we can say that both of the triangles are similar, because automatically the third angle should also be the same, because all the angles in any triangle adds up to 180 degrees. Let's take a look at these triangles here. So let's try to identify at least two angles that are the same in both of these triangles. Let's see if we can find that. So let's take a look at these triangles. And first of all, I see this angle as 50 degrees. Now, let's take a look at the other triangle, and we also see one angle, 50 degrees. So at least we have one angle, but we need one more angle, okay, to conclude that these triangles are similar. Now, let's take a look here. We have 75, and here we also have 75. So because we have at least two angles the same in both of these triangles, we can conclude that both of these triangles are similar. So since both of these triangles have two angles with the same measure, we conclude that both of these triangles are similar. That they are similar. That's it. Since we found that two of these angles are the same in both triangles, both of these triangles are similar. Okay, that's one way of finding similarities between two triangles. Now let's take a look at another example here. Here we have this triangle. Here we have x degree. We do not know this angle, but we know the other two angles. And here we know two angles, but we do not know another angle. Now, always look to see if both of these triangles have any angles in common. We see here that this angle is 63 degrees, and the other triangle has also an angle that is 63 degrees. But the other two angles don't match. Now, we have to find either this value of the x in this triangle and see if we get 63, or we can find the value of the y here and see if we can get y to be 54. So either way, okay? So let's choose the first triangle. You can choose any triangle you want. Let's choose the first triangle and let's find the value of x in these triangles first, okay? And see if x would be 63. If x would be 63, then we can conclude that both of these triangles are similar. So let's solve for x there. Now we know that all the angles in any triangle add up to 180 degrees. So let's add all of these three angles. So we have x degrees plus 54 degrees plus 63 degrees equals 180 degrees. Okay? And now let's solve for x and find the value of that angle. Okay? Now we have a multi-state equation. That's why equations are so important. I've been telling you over and over. We need to know how to solve multi-step equations because they're very applicable. Okay, so let's combine the like terms now. So let's add 54 plus 63. If we add 54 plus 63, we get 117 degrees. So we have x plus 117 equals 180 degrees. And now we just simply have to subtract 117 from both sides. 117 minus 117 and see what we get. 117 and negative 117 cancels out, so we get x equals, let's borrow from the 8, make 8 a 7, make 0 a 10, 10 minus 7 is 3, 7 minus 1 is 6, and that is 63 degrees. So the value of this angle here is 63 degrees. Now, we have another angle in this triangle. Here we have 63 and this is also 63. So because we have, again, two angles that are the same in both of these triangles, we can conclude that these triangles are similar. And the answer is yes. Yes. They are similar. For the reason that both of these triangles have at least two angles with the same measures. Let's take a look at another example here. Now here we have this triangle and this triangle. The question I have for you is, what do they have in common? Obviously 42 does not match 38, so they are different angles. But we know something that they have in common. We know that both of these angles are 90 degrees. 90 degrees and 90 degrees. Remember, a little square there by a triangle, inside of a triangle, means that that angle is a 90-degree angle. 90-degree angle, 90-degree angle. So at least now we have one angle. But how many we need? At least two angles. And if we identify another angle, and we identify that both of these triangles have another angle in common, then we can say that they are similar. Now let's randomly choose. Last example we chose the first triangle. Now let's choose this triangle and let's solve for x. Again, adding all the angles in this triangle and equaling, adding the angles and equal 180 degrees. Because remember, all the angles in any triangle adds up to they add up to 180 degrees. So let's start with this angle here. Y plus 90 plus 38 equals, again, 180 degrees. And let's see what we get. So again, we have to combine the like terms here. So we have y plus 90 plus 38 becomes 128. So plus 128 degrees equals 180 degrees. And finally, we have to subtract 128 from both sides so we can solve for y. 128 and negative 128 cancels out, so we get y equals, let's subtract here, bottom from the 8, make 8 7, make 0 10, 10 minus 8 is 2, and 7 minus 2 is 5, so we get 52 degrees. So this angle over here is 52 degrees. So we have 38, 52, 90. Here we have 90, 42. Obviously, we're not going to get another angle. X is not going to match because here we have 52 and 38. So none of these two are 42. None. None of these are 42. Therefore, the answer is no. Not similar. Not similar. Again, these triangles don't have any two angles the same. So because of that reason, we can conclude that these triangles are not similar. Let's take a look at one more problem here. a challenging problem. Let's take a look at this word problem and see if we can solve the problem. You plan to cross a river. This is a river right here. You plan to cross this river and you want to know how far it is to the other side. You want to know this distance here. You want to know the distance from D to E. And that's going to be our unknown. That's our x. You want to find the distance from D to E. You take measurements on your side of the river and make the drawing shown right here. So you take some measurements here on your side of the river. Okay, you are on this side of the river and you want to cross on the other side of the river right here. And you're taking some measurements, right? Take a look. So it says here, A, explain why triangle ABC, and triangle DEC and triangle DEC are similar. We need to explain that. And B, what is the distance x across the river? So if I identify this triangle and these triangles are similar, then we need to find the value of x. Now, when you are conducting some measurements, again, since we have that square there and the square there, we can conclude that these angles are both 90-degree angles. 90-degree here and 90-degree here. Okay? So at least both of these triangles, triangle ABC and CDE, they have one angle so far the same. This is 90 and this is 90. What else do they have in common? Take a look at this triangle and at this triangle. Take about a minute. You can share with someone next to you or with the member of your family or your friend and tell me if these triangles have anything in common. Okay? Pause the video, share, and then share back or take a look if you have the same answer. We see that this triangle ABC and triangle CDE or DEC have this angle in common. This angle over here and this angle over here are congruent because we learned in the previous lessons that these angles are opposites from each other. So remember, if we see angles that are opposite from each other, these are congruent, right? They are vertical angles, and vertical angles are always congruent. So now we know already that this triangle and this triangle have these angles in common. Therefore, since both of these triangles share two angles the same, they are similar. Okay, so triangle ABC, so we can say triangle ABC, it's similar, that's the sign for similar, to triangle DEC. Triangle DEC. Okay, ABC, triangle ABC are similar, right? We just proved it because they have two angles the same, right? We just proved it. And now because both triangles have two angles the same, their corresponding sides must be proportional. Okay? So let's take a look at some corresponding sides and set up a proportion and then solve for x. Let's start with x. This is the value. This is what we need to find. This is the distance across the river we need to find. So we can set up a proportion. X over. Now we need to look at the corresponding side from the other triangle. So the corresponding side from the other triangle must be this side, side AB, which is 60 feet. So we can say x over 60 feet. We can put the feet at the end. In the end, so x over 60 feet, x feet over 60 feet, right? X feet over 60 feet. Now we can say equals 40. This side here that's close to 90, so 40 feet over the corresponding side from the other triangle, which is this side here, BC, which is 50 feet. Over 50 feet. Okay? You see, we set up a proportion, right? X over 60 should equal 40 over 50 because we already know that both of these triangles are similar. We proved it. They have two angles the same. Now we can solve for x. And to solve for x, we are going to use the cross multiplication method we've learned in the previous year, right? We can multiply across like a butterfly. X times 50 becomes 50x. 50x equals 40 times 60. 40 times 60, okay? And let's see what we get. Now, 40 times 60, the easiest way to multiply 40 times 60, we can multiply the whole numbers. 4 times 6, which is 24, and then add 2 zeros. So that becomes 24, and add the 2 zeros, 2,400. And here we have 50x equals 2,400. And now we just simply need to solve for x. So to solve for x, we have to divide both sides by 50. So let's divide both sides by 50 and see what we get. 50 on both sides. We can divide here by 50. Obviously 50 and 50 simplifies. So we get x by itself now equals. We can simplify. We can cross a 0 from the top and a 0 from the bottom. Okay. And now we can simply have to divide 240 by 5. Let's divide it right here. 240 divided by 5. Let's see what we get. 5 goes into 24 4 times. 4 times 5, 20. Let's subtract. 24 minus 20 becomes 4. Bring down the 0. And 5 into 40, 8 times. 8 times 5, 40. Okay, so our answer is 48. X equals 48 what? 48 feet, right? Because we were trying to find the distance. So that's it, folks. The distance across the river is 48 feet. You see how we set up this problem? First, we had to identify if both of these triangles are similar. And once we found that, we set up the proportion. X over 60, corresponding sides. X over 60 equals 40 over 50. And then we use cross multiplication. Cross multiplication. Cross multiplication. We used cross multiplication and then we solve for x. Thank you all so much for watching. Please don't forget to like and subscribe and share this video with all your friends, classmates, and make sure you prepare for all your tests and quizzes, and especially at the end of the year, I want you all to be proficient. Remember green? Proficient. All the best to you.